Hi, welcome to EC&M Tech Talks. This is a series of how-to videos where we cover everything from the equipment that we install and maintain out in the field, safety aspects associated with our everyday work, and the codes and standards that apply to us to make sure that we're always in compliance, right? And this is just one in a series of many different tech talks that EC&M offers. If you haven't already, you need to go to ecmweb.com. So go to ecmweb.com, and in the upper left-hand corner, there's a drop-down menu. Go ahead and click on that drop-down menu, and you'll find the very first line, Premium Content. Make sure you sign up for that premium content if you haven't already, and it'll give you access to tons of free information. It's free to sign up for the content. Gives you plenty of information on the topic we're going to be talking about today, which is our OSHA requirements for electrical safety out on the construction job site. And then it gives you just, anything you want to know in the world of electrical construction and maintenance, I say you'll find it there at ecmweb.com. So I'm Randy Barnett. I'll be your host for this particular tech talk. And as I say, today we're going to be talking about OSHA federal regulations. So this is Title 29 of the Code of Federal Regulations. And we're not talking about a best practice or an industry standard or a good way to do your work. We're talking about federal regulations right now. So we have to comply. Not only that, it makes sense. We want to keep ourselves safe. Now, typical of the Code of Federal Regulations, then, it's probably not going to give us all the information that we know, that we need to know to go out there and be safe. So we're going to look at some supplemental information as well. This is 1926, Part 1926 of Title 29, and it is the construction safety requirements then. 1926, that's what it's about. Now, that part has many different subparts to it. We want to talk in particular about Subpart K, which is our electrical requirements. Subpart K is divided up, well, I'd say 4 main sections. There's some general information up front that's going to help us. And then it's divided up. It covers installation and wiring requirements for construction job sites. It covers safety-related work practices. Then it gets into some of the environmental considerations for our equipment and special equipment. And things like maybe battery chargers, right? Anyway, we're going to concentrate on these first 2 areas today. We're going to talk about our installation and wiring practices on the job site and our safety-related work practices, because really, these are the things that probably matter to us most when we go out there. Now, number 1, we're going to talk about installation requirements, okay? We're not talking about the NEC requirements for building the building, the written specifications, the prints that we're using and all of that. We're talking about bringing in the temporary power and lighting onto our job site so that we can get the building built. That's what Subpart K is talking about as far as installation and wiring. Now, what's interesting is it says that, hey, why don't you go ahead and if you'll just use the National Electrical Code and follow the National Electrical Code, you'll be in compliance with the installation and wiring requirements found in Subpart K. It says, except, the code that they reference, the one you need to use, make sure you're in compliance with, is the 1984 edition of the NEC. So when you're out on the job site, just whip out your 1984 code book and that's crazy, huh? No, OSHA has many different letters of interpretation, and somebody had, asked OSHA, what do we do with this? I mean, that code is 40 years old, right? Or going on 40 years. Is that really the one we should follow? Well, through the letter of interpretation, OSHA wording talks about following your latest codes and standards is what you want to do. So we're going to talk about the 2023 NEC today, because that's what I'm using. That's the latest edition, and it's going to give us the most up-to-date information. So we're going to go through and we're going to look at some of the temporary installation requirements found in Article 590 of the NEC. The second part then gets into the safety-related work practices, and we'll get to that. So let's begin by talking about the installation and wiring requirements out of Subpart K, which, as I say, really is going to take us to Article 590 of the NEC. When we take a look at Article 590 of the NEC, There's some general information up front. And then one of the first things it gets into is about time constraints. And remember, we're talking about bringing the installation, bringing in the power and the lighting in order to get our building built. We're not talking about building the building. So there's temporary power and lighting we bring in. How long can I leave it up? As soon as I'm done with the job, it comes down. That's what it tells me. Temporary power and lighting must be taken down as soon as my installation or maintenance work is done. Now, it also talks about holiday decorative lighting. It says holiday decorative lighting can only be up for 90 days. Then it's got to come down. Where we get into that in the electrical construction world is large building, maybe commercial building. We need to get some temporary power rigged for them so that they can go ahead and install all of the pretty colored lights and whatever they're going to do, right? That needs to come down within 90 days or at the end of 90 days. I can't leave it up. People say, well, just leave it there because we're going to be, 10 months, we're going to put all these lights back up. So you might just tuck that over there out of the way somewhere and just leave it installed. No, I can't do that. 90 days on holiday decorative lighting then. Now, the next section that the NEC gets into in Article 590 is going to talk about some different general information about, for instance, installation and wiring methods that I can use. So, for instance, it tells us that for these temporary installations, I can use up to any height. I can use type NM cable. Right, what you and I call it, Southwire's trademark on it, trade name is Romex. So we install this Romex, don't we? You see that a lot for temporary lighting in buildings. Oh, and it also tells us in Article 590 as well as Subpart K, I have to have some physical protection around those individual lamps. Makes sense so they don't get broken. NEC also says if those lamp holders I'm screwing into are metal, they have to be grounded. We understand that. That makes sense to us then. Now, the NEC says that in addition to the type NM cable, I may use some hard service cable. So something like, for instance, this. Here's some, you say, oh, that's some SO cord. Well, we use that term all the time, don't we? Well, what we need to do, because the code book says I can't just use any type of flexible cable. It has to be hard usage. Hard usage, I don't know if this is hard usage or not. I look on here and it says it's gives me some information. 3 conductor, 6 AWG. It says SOOW, 600 volts, and goes on from there. So it's type SOOW. Nowhere in here does it say hard usage. So I need to go back to Chapter 4 in the NEC, Article 400, and take a look at cables. There's a table in Article 400 that's going to tell me that SOOW is in fact a hard usage cord cable, and I can then go ahead and use it according to Article 590. Now, lots of times we just say, well, that's SO cable. No, it's not. It says it's SOOW. It depends on what you're using. SO is hard usage, so is SOW, and so is SOOW. The S, hard usage, the O, there's actually 2 O's in the SOOW, right? One of the O's tells me that the insulation on the conductors is oil resistant. The second O tells me that the jacket on the outside is also oil resistant. And then the W tells me that it's suitable for a wet location. So obviously that's important to know, especially in the construction world, isn't it? Another type of wiring method that I can use in the job site for temporary power and lighting is service entrance cable, type SE. We'll get a big chunk of that. There we go. Not bad, it's all aluminum, right? And so here is my Article 338 type SE service entrance cable. Now, if I go to Article 338, it's going to tell me lots of information about this. For instance, this cable is plexed, which is fine. It explains to me in an informational note what that means. It says if I take these conductors and I twist them around, the manufacturer does that, of course, and that is plexing the conductor. Then they take and they put some tape around the outside to give it some physical strength, and then it has a sunlight-resistant PVC jacket on the outside. This is type SE, service entrance cable. Then the manufacturer on here also says something about SER after the SE. And that's okay. That's the manufacturer's information. The bottom line is it's Article 338 compliant type SE cable, so I can use it. I have my 3 conductors, which are insulated. These happen to be 2 AWG aluminum. So I could use this for a 100 amp service, couldn't I? Anyway, my conductors are insulated with either XHHW or THHN insulation. Manufacturer's taking care of that. Then I have one conductor that's slightly smaller, and it's aluminum, bare aluminum. If I'm using this, which I can for branch circuits and feeders out on the construction job site for my temporary power, I can use my 3 conductors, of course, as my ungrounded phase conductors, and then the bare aluminum conductor, I can use this as my equipment grounding conductor. 250.118 tells me that. 250.118 tells me what I can use for my equipment grounding conductor, my EGC then. And it says I can use either copper, I can use aluminum, or I can use copper clad aluminum. And of course, this is an aluminum conductor. So I can use that as my equipment grounding conductor. So anyway, commonly used, right? Type SE cable for branch circuits and feeders on construction job sites. No problem doing that. Just follow your requirements. In fact, as we go through this information, remember that I'm just hitting the high points out of the NEC. What you need to do is jump into your NEC book, whatever edition you're using, that you're required to use, right? And go into Article 590 and look at all of the details. For instance, splicing, we think about, oh yeah, anytime we splice conductors, that's got to be in a junction box and so on. Take a look at the exceptions in Article 590 on your splicing requirements and for conductors. You'll see some differences there. Another big item is receptacles, isn't it, out on the job site. We have receptacles that are part of the permanent wiring of the building if we're doing maybe some retrofit work or certainly maintenance work and so on and so forth. But if we're under construction building a new building, we probably don't have any receptacles that are part of the permanent installation yet that we're able to use. And so we end up having to bring in that temporary power to those receptacles and so forth. So our general rule we're going to find here is anytime that I am using receptacles that are not part of the permanent wiring of the building, I got to protect myself from shock. Circuit breaker's not going to do it. 20 amp circuit breaker, that's designed to prevent a fire. I'm history long before that breaker's going to trip, right? So we need to use something else. A couple of things. One is very common on a job site. We're going to use GFCIs, aren't we? So a pigtail like this. Got the attachment plug on one end, the other end's a receptacle end, but in the middle, I've got my GFCI, ground fault circuit interrupter. It's going to trip somewhere between 4 and 6 milliamps in order to protect me on the job site. I plug it in, it trips, that's my self-test for it, then I reset it, and off I can go to work. Something else that Article 590 talks about is the Assured Equipment Grounding Conductor Program. That's an OSHA requirement. So I'll find information in 1926, Subpart K. I'll find information in the NEC Article 590 on this Assured Equipment Grounding Conductor Program. And that's where I bring a cord set or a cord and plug connected power tool on site, and I have to check it and make sure that I have continuity from the attachment plug along that equipment grounding conductor to the opposite end of whether it's a cord set or a power tool or whatever it is. For safety reasons, right? I have to have a written program in place to document that I've done that. I have to identify that cord that has been tested. Quite often we'll do that maybe with some colored marking tape. And every 90 days I've got to get that done and make sure that my equipment is safe to use. So anyway, very specific requirements, more details in that on Article 590, as well as lots of information, some other helpful information too, general information from OSHA on that Assured Equipment Grounding Conductor Program that you must have in place on that construction job site. So my installation requirements, receptacles, lighting, time constraints, types of conductors that I use and so forth, take a look at Article 590 and you'll find lots more detailed information. let's talk about the second section of the Subpart K regulations. And it talks about protecting ourselves and our fellow workers out there. These are our safety-related work practices. Now, according to the OSHA requirements, there's not a lot of information in Subpart K. Not enough for me to go out there and do my job safely. What I have to consider whether or not I'm exposed to any electrical hazards, shock or arc flash, right? For the most part, much of our construction work, we're not exposed to those electrical hazards. Bending pipe, pulling wire, those type things. Really you're not going to get into shock and arc flash hazards during that. However, keep in mind, there comes a time in our construction project where for the very first time, we've got to heat things up, don't we? We're going to apply some power to those panels that have never been energized before. And our job is to go in maybe and make sure that it works properly, do some troubleshooting, fix whatever's not working right, and all of those type things. Now, in that case, I'm going to be exposed to hazards. So let's talk about that a little bit. Not enough information. In fact, it's Subpart K gives you some general statements about protecting the worker, which is good, from shock. Really nothing at all about arc flash. And it says, hey, if you're going to go out there and use something like a jackhammer, and you're not sure if there's any cables underground or not, or underneath that concrete, whatever you're doing, get yourself some rubber gloves. This is the requirement, and it says wear some voltage-rated rubber gloves in order to protect yourself while you're out there using that jackhammer. Well, that's a good idea. And there are requirements, as we know, in the testing and inspection and all of that in 70E. But if you think about it, I'm not just going to take a jackhammer and go out there and start working and go, well, I'll put on these rubber gloves in case there's something underground here I shouldn't, under the concrete I don't know about. I'm required in every state in the United States, as well as throughout Canada, to call that in the U.S., it's that 1-800-DIG number. And make sure that I meet my compliance requirements, that I'm not going to get into anything underground that I shouldn't be getting into. Different states, different requirements. I know one state has, you can go up to 16 inches down before you have to call 1-800-DIG. Another state says, hey, if you're going to break the surface of the earth, you got to give us a call first. So anyway, follow your particular requirements in your state, your jurisdiction, your job site, whatever it is you have to do. Make sure that's getting done before you start doing any work underground. Big safety issue there. Lots of bad stories about that, right? We don't want to be part of that. So anyway, we're going to have to look in the NFPA 70E if we really want to find out then how to be safe out there on the job site, huh? And so what it boils down to, without going deeply into 70E, because that's another fact, we've had other tech talks on that. But with 70E, what do I have to do? I got to do a job safety analysis, JSA, before I do my job. I got to make sure, what do I do? What's the purpose of that risk assessment? Make sure the job is safe for me to do. If it's not an acceptable risk to me, the worker, and to people above me, then the job doesn't get done until we lower to an acceptable risk. So whatever we need to do to make it acceptable to us, the worker, then we can go out and get the job done. We also have to select the proper PPE for the job. So whatever our PPE is, if we're going to expose to shock arc flash hazards, we may need voltage-rated rubber gloves. We may need some arc-rated PPE. Very common out on the job site, right, is we have to wear our high-vis vest. And somewhere here's all the visibility. There we go. And so we have to wear our high-vis vest. Now, this is not arc-rated. So I could not wear this if I were exposed to an arc flash hazard. However, I can buy an arc-rated vest. So here's an arc-rated vest, and I can use this one on an outer layer of my clothing if I'm exposed to that arc flash hazard. Now, this one is rated for 9.6 ATPV. So this will withstand 9.6 calories of incident energy for 1/10 of a second. However, what if I have to go out, and let's say that I'm doing some work, and if I'm doing construction, I'm probably not going to see the arc flash warning labels on my equipment yet. So I'm probably going to have to use the table method during a lot of my commissioning work to go into NFPA 7E and determine what ARC-rated clothing I wear. Another whole topic. If you're not familiar with it, you need to learn the PPE category method then. So, PPE category method. Let's say I have to wear some Category 3 clothing rated for 25 calories. However, this vest is only rated for 9.6. That's okay. I can still wear my 25 cal coveralls or whatever it is, and then I can put on my 9.6 calorie vest over that. If I'm in an arc flash, this guy's destroyed. That's okay. Its purpose is not to protect my skin from burn injury. That's the 25 cal coveralls or whatever I'm wearing. So PPE selection. Understand the different category methods and understand what you can wear. Cold weather, we might want to wear a heavy jacket, right? That's okay. Take a look at your calorie ratings. It does not need to be at the same calorie rating you need to protect yourself then. So take a look in 7E on all that. Now, another thing we got to do, so let's see. We've done our JSA. We've looked at some PPE. We got to establish some barricades. And on a construction job site, we're going to do that, of course, the limited approach boundary or the arc flash boundary, whichever is greater. But you got to protect everybody out there. And on a job site, there can be a lot of stuff going on around you, right? So keep that in mind when you set up your physical barricades. You also have to look at the equipment and make sure it's suitable for normal operation. You're going to maybe energize this equipment for the very first time, or even if it's temporary power equipment, and you're installing this temporary power equipment. Once again, you got to make sure it's suitable for normal operation. There are 7 requirements for that outlined in NFPA 70E. So once again, use your NFPA 70E and what I call electrical common sense. Take a look at that equipment and make sure it's safe to operate before you do. Then finally, probably and definitely, I should say, the best thing we can always do is what? Article 120 of 70E, create an electrically safe work condition. Lock it out, tag it out, man. Make sure it's dead before you stick your hands in there. That's what we're talking about, right? So follow the requirements in NFPA 70E. Did you know that for every 100, pretty not a fun statistic, but for every 100 fatalities on the construction job site, 8 of those fatalities are electricians? Well, that's not a good statistic, but it's a number, right? But if you put it in this perspective, if you've ever been to any of my training classes, this is how we talk about it. I would tell you that for every 100 families who get a phone call that their loved one is not coming home today, 8 of those phone calls are to families of electricians. Now, that kind of makes it hit home, and not to, delve into that, but think about that, okay? Yeah, safety is a huge issue, especially out in the construction world. If you've been and you have to other safety meetings and toolbox talks and OSHA 10 or OSHA 30-hour training and all that, you know that electrical work is considered one of the fatal 4 when it comes to electrical safety in construction. And why is that? Well, there's lots of reasons, but the bottom line is we need to get that number down there. And in the last many years, it's really not been going down. Oh yeah, it took a big drop 30 years ago or so, but it's kind of leveled out. We still got way too many. In fact, 1 fatality a year is 1 too many, isn't it? We don't need any injuries enough from electrical on the job site. There's already enough bad stuff out there that can get us in trouble. So we need to protect ourselves. So anyway, that's our requirements in a nutshell from 1926, Subpart K, our safety requirements for electrical on the construction job site. So jump back into Subpart K as you need to, take a look at that, but then for a lot of your technical information, you're going to need to jump into that National Electrical Code, especially Article 590, as well as the rest of the code, and take a look at NFPA 70E and make sure you keep yourself safe out there on a job site. That's all the time we got today, so we're going to wrap it up. Remember, this is brought to you by EC&M Magazine, produces all of these tech talks. They're part of the Endeavor Business portfolio of business publications. Thanks for watching today, and the bottom line is you go out of here and you keep yourself safe, right? Until the next Tech Talk, work safely.